Hi, this is Brian. I'm going to be giving a brief demonstration of a project that's related to some work I've done for a previous employer and something that I continue to work on today because I think it's a great machine learning problem. The application I'll be showing you simulates a network of radiation sensors. It runs an algorithm that has a Bayes-net and particle filter, and it calculates the posterior probability of an unknown source being present. It also uses the mean location of the particles to determine a prediction for where it thinks the source is. The application has three windows. On the top left is the status, which shows the current status of the algorithm. Once a source is detected, it will show true here, and the best estimate of the source location will be shown here. The bottom left is a console, which displays a log of all the algorithm output during the run. On the right is a heat map display, which shows the current location of the detectors, the source, and the particles. The detectors are shown as grayish circles, and the source is a green circle. The particles are squares that are colored according to their weights, with dark blue being the lowest weight and dark red being the highest weight. The simulation I have configured will run for a fixed time of 20 seconds. For the first 5 seconds, the source will not be present, but then appear at a location of 25 by 28 meters and remain there until the rest of the run. Let's go ahead and start a simulation. Once the simulation is started, detectors will begin to take sample measurements in the form of counts, which is a combination of radiation from the background and any existing sources. These observations will then be used to update the Bayes-nets and particle weights, with the higher weights more likely to be resampled. Particles can also randomly die off and respawn to avoid the algorithm getting stuck. With the source not present, particles are low weighted and spread out. Once the source has appeared, detectors will receive more counts, and particles that are more consistent with the observations will be higher weighted, and the particles will begin to converge around the source. The run completes with a predicted source at about 1.5 meters from the true location. That concludes my demonstration. For further details, please check out my code blog at the address given below. Thanks for listening.